Okay, question 6 is again to do with cubic equations, and this time we're looking at graphs of cubic functions. We're given the graph of a function, and we can see there's 4 unknowns that we're looking for, and we're going to have to find those from the graph. So let's have a look at this graph and see what we can work out. First of all, there's one point that we can identify here, and that is the point 0, 24, and obviously that is on the graph. Okay, another point that we have is this point here, so that's x is equal to 3, and that is a root of our graph. That's a point where it crosses the x-axis. We have another root here at x is equal to minus 2, and that is a repeated root, because we can see that the graph touches but does not cross the x-axis at that point. So we have our 3 roots that we need, and then we also have a point on the graph, and that's going to come in useful for us as well. What we have to remember here is that even though we have the 3 roots, to find a specific cubic equation where we're given a point like this one, we need to introduce an integer factor. And we usually use the letter a for these integer factors, and that's fine. So let's do that, just I suppose not mixing it up with the a that we already have in the question. So we're rewriting these factors as roots, and that is, I suppose, a simple way of writing our equation. Okay, at this point let's use, so we're going to use the point that we know is on the graph, which is 0, 24. And what that means is if I sub in x is equal to 0, my y should be 24. So let's do that. Okay, we can do it at this point here, it's completely fine. That should be equal to 24. So a by minus 3 by 2 squared should be 24. So minus 3 by 4. So we have minus 12a is 24, which means that this a is minus 2. Just being careful there, I suppose, that we don't mix that up with the a in the question. You might want to use a different letter. You could use a different letter. I think in the solutions I used the letter or. It doesn't really matter. You might want to just use a letter that's not in the question. But anyway, here it's the same thing. So a is minus 2. All that means for us is that our, I suppose, general expression for this quadratic is going to be this here. So minus 2, x minus 3, x plus 2 all squared. So let's just take that down here and multiply it out. So we'll keep the minus 2 here, we'll maybe keep the minus 3, and we'll multiply out the plus 2 first. So x squared plus 4x plus 4. Then we'll keep the minus 2 again until the end, so we can multiply out the next little bit. And that's going to give us x cubed minus 3x squared plus 4x squared minus 12x plus 4x minus 12 is equal to 0. And we can maybe tidy up what's on the inside here. So x cubed plus x squared minus 8x minus 12, 0. I'm just rewriting that now, multiplying across by that minus 2, minus 2x cubed, minus 2x squared, plus 16x, plus 24. So we have that a is minus 2, b is minus 2, c is 16, d is 24. And those are our 4 answers for that one. Key thing there being recognizing those roots, remembering what it means for a root to be repeated, and what that looks like on the graph. So not alone knowing that it can happen, but how do I know what that looks like? Recognizing the other root, and then this integer factor here, this a. Okay, this is the integer factor. Remembering to introduce that. And we did a good few of these examples when we did it in class as well, but it's just remembering that without that integer factor, you haven't necessarily found this specific cubic equation. You've just found a general cubic equation that would have these same roots. So that's why they generally will always give you a point on the graph, like 0, 24. Usually the the y-intercept. So we can see there that point 0, 24 is actually the y-intercept, which is the letter D, the last term. It's the term that has no